some modern hunter-gatherer groups, if they run out of females, they will go and steal some from a neighbouring group. So maybe Homo sapiens actually stole Neanderthal females into their group to breed with them.
Wow, fascinating.
But whether it was voluntary or not, this movement of Neanderthal breeding individuals into Homo sapiens means that they're being lost from the Neanderthal breeding pool. And if you haven't got many people, that's very bad news. If you're losing your prime age breeding individuals to this other population, that is going to add to the extinction problem.
It is with the utmost pleasure that I'm welcoming back to the show Professor Chris Stringer, an anthropologist who's nothing short of a legend in the field of human evolution. Professor, really appreciate you coming back on.
Okay, no, it's good to be with you again.
Now, since we last spoke, I hosted Harvard astrophysicists searching for extraterrestrial life, doctors studying near-death experiences. I even had a conversation with a former KGB spy. And yet, as far as numbers are concerned, whether we're talking audio downloads or views on YouTube, nothing comes even remotely close to the human origins episode I had with you almost 2 years ago, I think. It still easily reigns supreme. So it seems that when all is said and done, the questions we are most interested in are who we really are and where do we come from. Professor, is that perhaps the ultimate proof of the vanity or egotism of our species, or am I being too harsh here?
Yeah, I mean, yes, you could say it's vanity, but yeah, it's a curiosity too. We're a curious species, and knowing where we came from, yeah, and unfortunately, of course, where are we going? That's another issue, much more difficult to answer. Right,
but most curious about ourselves.
Yes.
I mean, this is not like an empirical study, but...
Yeah, I mean, I think we shouldn't be, of course, most interested in ourselves. We should be interested in all living things. We're part of the natural world. So I suppose that, this is a way into looking at our place in nature, our place in the wider world. Yeah. So I don't see it just as being just about us. It's about our relatives, not only our dead ones, but our living ones too. So, yeah, I think this should be part of our natural curiosity about why we're here and how we relate to the rest of the natural world.
Thank you for putting it in a much healthier context than I did. I went straight to the Eastern European cynicism, but that's much more helpful. So last time we discussed the world of the 5 hominin species that, at least for a while, coexisted on this planet, which for us today seems kind of freaky. Other types of humans running around. We're just not used to that. This time, however, I figured we would narrow it down to a group who probably intrigues us the most, at least I'm speaking just for myself, and that's our cousins, the Neanderthals. Okay, let's start maybe with this. What would you say is the most misunderstood thing about the Neanderthals?
Yes, so the place of the Neanderthals, their relation to us, it's a long and complicated story, and I think even though we try and make the point all the time that Neanderthals, at least in my view, are fully human, they are very like us in most ways. They shared a lot of our evolutionary history. Nevertheless, there is this long-standing view of Neanderthals as representing this lesser kind of humanity, the brutal side, if you like, of humanity, bad behavior. Unfortunately, it is still used as a term of insult. We hear, when footballers behave badly or football fans behave badly, they get called Neanderthals. When politicians get called Neanderthal, I mean, Trump's been called a Neanderthal. I think that's insulting to Neanderthals.
Okay, fair enough. Let's go to the absolute basics. When do they appear and where are they coming from?
It depends who you ask is the first answer, really, because not everyone agrees on how to recognize what is a Neanderthal and where they came from. My views are changing too, so I think we've got a lot of new evidence recently. So I would say the Neanderthals are one of our closest relatives. So I might have said 15 years ago, they are our closest relatives in the fossil record. Now we know about these other people called the Denisovans. that were living in Siberia until at least 50,000 years ago. So they and Neanderthals and us are all closely related, and views differ on which of them is actually our closest relation. So whereas a lot of genetic data at the moment suggests that Denisovans and Neanderthals are closely related to each other, more closely related to each other than they are to us. I've been involved in a collaboration with a Chinese paleontologist called Zhiyong Ni, working on a wonderful fossil from China known as Dragon Man, the skull of Homo longi. And in our work, actually, it suggested that the Homo longi group is more closely related to us than Neanderthals are. And now it seems increasingly likely that the Homo longi group are actually Denisovans. They're one and the same thing. So we've got this third lineage over in Asia. There's us, having evolved in Africa over the last 500,000 years. There's the Neanderthals evolving in Europe and Asia over that same time period. And over in the Far East, we've got these people called the Denisovans. So it's unclear at the moment which of them are our closest relatives, and it's unclear when we had a common ancestor. So to say when the Neanderthals began, we need to know when we had a common ancestor with the Neanderthals. And the genetic data suggests it was maybe 600,000 years ago, which is, a long time, but not a long time in terms of total Earth history. So on that basis, we think that geneticists estimate we separated from the chimpanzees maybe 7 million years ago in evolutionary terms. The Neanderthals then are 10 times closer to us than chimpanzees are. They share most of that evolutionary history until about 600,000 years ago. But my work on Dragon Man with Zhiyong Ni and colleagues suggests the common ancestor might be even further back, could be closer to 1 million years. So that's the first issue. When did we have a common ancestor with Neanderthals? When did their lineage begin? It could be 600,000 years. It could even be as far back as 1 million. And where did that common ancestor live and what was it like? So 10 years ago, I would have said the common ancestor is a thing called Homo heidelbergensis. This is part of a description. It's a group of fossils that were around about 500,000 years ago. And we know of them from Europe and from Africa, probably from Asia too. And it includes things like the Kabwe fossil from Africa, so-called Rhodesian man. It includes skulls from Greece, such as Petralona, from France, Arago, from Ethiopia, Bodo. So in my view used to be that species was the common ancestor of us and Neanderthals, and then it went in separate evolutionary directions. In Africa, it became us. In Europe and Asia, it became Neanderthals. Now, I don't share that view anymore. I think Heidelbergensis and the fossils we put in it, and even the name is argued about what is the correct name for this group. I think that group actually don't represent our ancestors. I think it was a separate branch, and our common ancestor is more like a thing called Homo antecessor, pioneer man, which is known from Europe from about 850,000 years ago. And the common ancestor then went in its different directions, but it wasn't Heidelbergensis. So views are changing, and it depends who you are. So other people might start the Neanderthal lineage much later on. So the first fossils that we can really say are on the Neanderthal line are at the moment are ones from the Cima del Huesos in Spain, the pit of the bones. So it's an incredible site. Deep in this cave system, there's a blind chamber deep in the cave, and down there are over 6,000 human fossils from about 400,000 years ago. It's an incredible site. We think those bones were ended up down there because humans 400,000 years ago, or slightly older than that, they threw bodies down into this pit deep in the cave. And incredibly, they've been preserved for all that time. They do show Neanderthal features, especially in their teeth, and there are even fragments of DNA from bones in this pit of the bones that actually show they are on the Neanderthal lineage. So about 430,000 years ago, which is the current dating for this collection of bones, the Neanderthals were already evolving. And we assume, therefore, in Africa, our ancestors, Homo Sapiens, were already separate and evolving too.
So the fossils are, what did you say, 430,000 years old?
The
in
ones
Europe,
in the
right?
Cima del Huesos, yes, in Atapuerca, in northern Spain. Yeah.
Okay, interesting.
But they're
Is it
primitive.
fair
Just
to
to
say
say that
that?
they're
Yeah,
primitive Neanderthals.
please.
They don't show all the features of the later ones, but they certainly show some of the features, and particularly in their teeth, they show many of the distinctive features, little wrinkles and the shape differences in the teeth, which we find later on in Neanderthals.
Is it fair to say that the Neanderthals were more adapted to cold ice age weather?
That's been a common view, that, of course, they lived in overall colder conditions than our ancestors did in Africa. That's clear. But to what extent they were really obligatory, if you like, cold adapted is more arguable, because we know that they actually lived in warmer conditions as well. So in Italy, for example, we find Neanderthals alongside fossils of hippopotamus. So clearly they were living in warmer conditions. And there was a period about 125,000 years ago in Europe when it was slightly warmer than the present day. Well, we're coming to that warmth again now with global warming, but it was slightly warmer. And there were forests over much of Europe, and we now know the Neanderthals were doing well in that environment too. So they weren't just Ice Age people. We do find them later on alongside reindeers and woolly mammoths and things like that. So they could adapt to the cold, but they also were doing quite well in at least temperate conditions, not really hot, but southern European conditions in the Middle East, Western Asia. They were fine in those environments too. So not just cold adapted. And in fact, interesting, when it gets really cold, the Neanderthals disappear. So they weren't good in really cold conditions. Then they vanish. And interestingly, the Denisovans, these other people that were living over in the Far East, it looks like they were actually possibly slightly better cold adapted than the Neanderthals, because there are what seem to be Denisovans living up on the plateaus of the Tibetan Plateau. They were the remains from a cave called Baishir Cave in the Tibetan Plateau of China. And this is at an altitude of 3,000 meters, extremely cold at times. And these Denisovans, we know from DNA and probably from fossils as well, it's a bit more arguable, they were living there 100,000 years ago in some quite cold conditions. The Harbin fossil, the Dragoman fossil, which could be a Denisovan, that's up in northeast China, and that has some of the coldest winters in China. Even at the present day, the average temperature in winter is often minus 15 degrees. So Denisovans or Dragoman, they were living up there in northeast China 150,000 years ago. So possibly, yes, Neanderthals could live in cold conditions, but maybe these people in the Far East were living at times in even colder conditions.
That's unexpected, because in the popular imagination, we always associate Neanderthals with extremely cold weather and ice age and so forth. And I thought that even their features, like broad noses, barrel chests, that these were all like adaptations to cold weather. But
yes, some of
you're
them,
telling me that's not necessarily so.
I mean, they're overall, of course, the conditions overall, the ice ages dominated the climates of Europe and Asia for the last 500,000 years. So overall, the Neanderthals were living in colder conditions than the present most of the time. But when it got warmer, they didn't go away. They still did all right. But yes, that long-term adaptation under colder conditions, an average today, may have shaped their bodies to be shorter and wider, which is a good shape to be in the cold. And in terms of their big lungs and so on, that's more likely an adaptation that all of these earlier humans had. It seems that, by contrast, Homo sapiens is a kind of more economical energetically than some of these earlier species. They were demanding more of their environment. You could say that perhaps their technology was not as efficient in taking away the demands made on the body to get food every day. All the activities we do, we have tools to help us with those activities. These earlier humans did not have such complex technologies. They had to put more physical effort into their everyday activities. So living was hard for these people, and their bodies were built to withstand that. They were somewhat heavier, somewhat more heavily muscled, and not just the Neanderthals, but Homo erectus, an earlier species, their lung capacity could have been 20% bigger than ours. And so that's an energetic demand. They just require that extra fuel for their everyday activities. So we could be a more economical species, probably our technology has enabled us to reduce our body strength and our requirements for power and muscle compared with these earlier humans. So Neanderthals were part of that earlier kind of human that was still really, requiring a bit more energy out of the environment in terms of food. Their overall organs, probably their body organs in the trunk, were all a bit bigger than ours, a bit more demanding than ours. So they could have had bigger hearts equally, bigger lungs, as we've said, bigger other organs, processing food and so on. So their whole trunk was bigger, their pelvis was wider to support probably those larger organs in the middle of the body.
So they survived throughout different types of climates, right? But even so, in generally speaking, you'd say that the conditions they had to survive in were much more harsh than ours.
Well, of course,
or not.
Homo sapiens today live in very harsh conditions. Think of the Inuit. Think of the people up on the Tibetan plateau today. And think of people in the Sahara Desert. So we can live in even more harsh environments than these earlier humans.
Oh, wow.
Because our technology enables us to survive in those conditions. But if we talk about early Homo sapiens, yes, if we talk about Homo sapiens 100,000 years ago, obviously we didn't live in all those extreme environments 100,000 years ago. Like the Neanderthals, when the weather got really bad, Homo sapiens died out as well. So these very rapid climate changes that were happening affected all human populations. And so human population numbers for Neanderthals and for Homo sapiens were, by modern standards, ridiculously small. At times, we're talking of populations in the thousands or tens of thousands.
In total,
maybe
in the world.
I mean, maybe there could have been 1 million people worldwide 100,000 years ago of the different species. But by modern standards, we were small in number. And at times, the Neanderthals seem to have been very challenged. So from their DNA, we know that some of their populations were having to do breeding with close relatives. So they're inbred, their numbers are low, they're having to breed with close relatives. We know this from several sites where their DNA diversity is very low, where close relatives are having to interbreed. That's obviously bad for the gene pool because you can build up bad mutations. It reduces your diversity. So Neanderthals near the end of their time probably were suffering. You could say they were an endangered species, maybe, even without anything to do with Homo sapiens competing with them. So I think that because of these really, you could say these climate changes that kept happening. So from about 100,000 years down to about 40,000 years. So that covers the last 60,000 years we think the Neanderthals were around. The climates in Europe were changing very rapidly. So it would be nearly as warm as today for maybe 1,000 years. Then it would suddenly plunge into extreme cold for 1,000 years. And then it would switch back again. And this kept happening. So they were never able to keep their numbers up in the last 60,000 years of their existence in Europe. This eroded their numbers, it eroded their diversity. So I think by the time we get to 50,000 years ago, they were in trouble in terms of their gene pool being relatively small, their numbers being relatively small.
Is there any evidence? Probably not. I don't know if that's a ridiculous question, that in these harsh conditions or like harsh weather or climate change, they would ever try to make it to Africa?
We don't know if the Neanderthals ever made it to Africa. There's no reason why they couldn't have got there. We know that they were in the Levant, so they were in southern Israel. So yes, there's a site called Shukba, which is a cave site, and I was involved in restudying a tooth from there, a molar tooth found in, I think, the 1930s, and that is a Neanderthal tooth, and that's only a few hundred kilometers from Cairo. So they were that close to Africa. So at times, I mean, they wouldn't have known it was Africa, of course. If they were at Shukba in southern Israel, they wouldn't, they've got the Sinai in front of them. If it was actually relatively green and not desert, maybe they would have gone across it and gone into Africa. Maybe they did do that. We haven't got any evidence of it, but it's certainly not, if Homo sapiens could at times move from northeast Africa into that region, equally if the Neanderthals were there, why wouldn't they have been able to go in the opposite direction to Africa at times? We haven't got the direct evidence, but I certainly, there's no reason why Neanderthals could not have got into North Africa. Maybe they did.
Only time will tell.
That's right. New discoveries are going to
find anything
show this. And maybe if they came into Africa, there could have been some interbreeding even there. So we know there's this strange sort of still poorly understood period of time when maybe 300,000 years ago, it seems that early Homo sapiens met up with the Neanderthals. And they did interbreed even at that time. We know about the later interbreeding, and I'm sure we'll come on to that later. But it seems that there was a poorly known episode when Homo sapiens must have come out of Africa, maybe into Western Asia, and met Neanderthals and interbred with them. And as a result of that interbreeding, Neanderthals picked up some Homo sapiens DNA in that interbreeding about maybe 300,000 years ago. So we can find evidence of this in Neanderthal genomes, because if you look at the whole genome of Neanderthals, that suggests, as I mentioned, a separation from us of maybe 600,000 years to a common ancestor on the genetic estimates. But if you look at the mitochondrial DNA, which is a bit of DNA inherited through females, and you look at the Y chromosome DNA inherited through males, if you look at the Neanderthal Y chromosome and mitochondrial DNA, the divergence only comes to maybe 400,000 years. So the suggestion is that that interbreeding, maybe 300,000 years ago, replaced the Neanderthals' original Y chromosome and mitochondrial DNA with one that's more Homo sapiens-like. So they had a replacement of those bits of their genome by the Homo sapiens genome, and equally, that DNA probably went into Homo sapiens in the other direction about 300,000 years ago. So it's a very poorly understood one, which we can only model at present on the DNA and possibly on the archaeology, because around that time there was also a change in Europe and Western Asia and Africa from the kind of archaeology that was around before, which is often dominated by making hand axes. So these large bifacial tools, large cutting tools, these tools were very widespread in Europe and Africa and Western Asia until about 300,000 years ago. And then we start to see a change to a thing called prepared core technology, Levallois it's sometimes called, where the people, instead of taking a piece of flint and knocking off lots of flakes until you get the thing you want, which is a hand axe, they would actually map out beforehand the shape of the tool they wanted, and then with a single blow they could strike off a prepared flake close to what they wanted. So it was a different technique, and it became widespread about 300,000 years ago. So possibly the knowledge of that technology spread between Neanderthals and Homo sapiens 300,000 years ago. So it's a very interesting story. And in terms of early Homo sapiens fossils out of Africa, I was involved in studying a fossil from Greece, from a site called Epidima Cave in southern Greece. It's on the coast. It's a series actually in a stack of vertically stacked caves. And in one of them, in the roof of one of these caves, they found two skulls, which were thought to both be Neanderthal skulls. And I was involved in a restudy of these fossils led by Katerina Havati. And what she found with her work was that one of the skulls was Neanderthal and is thought to be about 170,000 years old. But the second skull, which is actually Epidima 1, it's only the back of a skull, but it actually looks like a Homo sapiens back of a skull. It doesn't look like a Neanderthal. So that fossil is dated at about 210, at least 210,000 years old. So this could be an example of an early Homo sapiens migration. It got as far as Greece more than 200,000 years ago, and it could be part of this population that interbred with the Neanderthals. So it's a more complicated story than we used to think. It seems that Homo sapiens made a number of excursions out of Africa before the final one, which is after 60,000. So the one at 60,000 years onwards is the one that gives rise to all the diversity outside of Africa today. And it's also the one that had the main interbreeding event with Neanderthals that everyone outside of Africa shows evidence of today.
Do we know anything about the social structures of Neanderthals? Let's say typically how many people were in a group? Was there a tribal leader? Did they practice patriarchy or maybe not? Was there division of labor between the sexes? Were they monogamous, etc.? I'm hitting you up with a lot of things.
Yeah, that's a lot of things.
I know, but can we be certain about any of these?
You need to speak to an archaeologist for most of those. I can say a little bit.
Right.
I mean, obviously, Neanderthal groups, we think Neanderthals did not have as large social groups as at least later Homo sapiens. So their groups possibly were more limited, maybe 20 or 30 people at times. And in terms of their mating structures, we've got a little bit of genetic data that suggests that they imported females into the groups. So you've got these groups of male kin, and the female individuals come in as partners from outside those groups. So when you look at the DNA of Neanderthals from a few sites, you can see where you've got a number of individuals that the male individuals seem to be closely related, but the female individuals are less closely related to each other. So this is a thing sometimes called patrilocal mating, which we find in many human groups today. So it's only slender evidence. Neanderthals seem to have done that at times. Whether it was universal, we don't know. But of course, that's interesting because it would have been, if that was what happened, then it would be the females bringing in knowledge from these other groups. So it's a way of information sharing. Females would have been the bearers of maybe new behaviors into those Neanderthal groups. But it seems that Neanderthals, their footprint on the landscape was smaller than the footprint of Homo sapiens from the same time periods. So when we look at the movements of raw materials, so we think of things like the material they're using to make stone tools, such as flint, we can track where that flint's come over a long distance from the isotope, from the chemical composition of the flint. You can map where it's come from. And in Africa, you can do the same thing for lavas and other raw materials. And the picture is that Homo sapiens seems to be extending wider across the landscape in terms of networks of trading and movement compared with Neanderthals. So Neanderthals probably lived more locally, and that also may have had implications for their technology, because obviously if you're in a smaller area and a smaller mating network, that may affect your innovation. So new behaviours may not arrive at the same rate as they would do if you had a wider footprint on the landscape.
But that was fascinating when you said that they met up to exchange women.
Yes, so
groups,
it looks
right?
like women, obviously we don't know the exact mechanisms, and obviously you asked about whether they were, did they just have single partners? We don't know anything about that.
Right. Of course. Yeah.
Maybe they
sense.
did, but we can't actually say. But yes, females came into the group from the outside. That's the pattern which we can, where we've got information, we can say that was the pattern. But of course, if we have more data, we may find that there were equally examples where Neanderthal males migrated, and you had a female kinship system where females were closely related and the males came into the groups. That pattern could be there, but at the moment, we don't have examples of it from the Neanderthals.
Well, is that a way to diversify their DNA pool? Is that what they did?
Well, yeah, of course. We've mentioned that having to breed with your close relatives is bad news for the gene pool. Neanderthals at times were forced to do that. We've got examples of Neanderthals as closely related as an uncle and a niece interbreeding, or half siblings having to interbreed. That's bad news for the diversity. So at times Neanderthals were having to breed with their very close relatives, but generally speaking, the diversity is obviously maintained by bringing in partners from a wider network.
What about culture? Is there any proof that Neanderthals, for example, did the things that we do, or similar things like dancing, playing music, making instruments, jewelry, religion, any of that
it's very
stuff?
tricky to know about some of those things. Neanderthal behavior was certainly more complex than we used to think. 20 years ago, I would have said there's a big behavioral gap between us and Neanderthals. They didn't make much use of raw materials like bone and antler and ivory. They didn't do any art. And things like that. Now, the gap between us and Neanderthals is much narrower. Some people say it's disappeared altogether. I don't go that far.
Wow.
Because there are some examples of Neanderthal markings on cave walls, engravings. There's a thing called the hashtag, which seems to be made by a Neanderthal in Gibraltar, maybe 45,000 years ago. And there are engravings on bones, zigzag marks and so on, and linear, what might be counting marks on some bones. So Neanderthals were doing that, but as far as I know, at least in my view, there's no representational art produced by the Neanderthals. So when we come on to 35,000 years ago, we've got lots of evidence of Homo sapiens. In fact, even earlier than that, there's caves in Sulawesi where it seems that Homo sapiens was painting animals on the cave wall 45,000 years ago. Pigs, wild pigs, for example. And we have the cave paintings in France at 35 to 40,000. Neanderthals, as far as we know, and also statuettes, I should say, from 40,000 years ago in Germany, we have lovely little statuettes of animals made of mammoth ivory, and even a female figurine from Germany at about 40,000 years. There's no evidence of that for Neanderthals. So at the moment, it doesn't look like they produce representational art, which seems to be unique to at least later Homo sapiens. But they were marking cave walls. They did apparently mark things symbolically. So making these zigzag markings meant something to the maker, and probably they were transmitting a message to another individual. So it's symbolic of some message which we can't interpret. So Neanderthals had that complexity. We know that they did make more complex tools. They certainly mounted, spear points onto handles. We know there's evidence even of adhesive that Neanderthals were making to keep these tools together. There's a site called Schöningen in Germany, dating from around 300,000 years ago, where you have the very rare preservation of wooden tools. And it's really quite striking just what a variety of tools were being made of wood 300,000 years ago. Now, we don't actually know the species that made those tools, because this other species, Homo heidelbergensis, was also around in Europe at that time. So it could have been heidelbergensis, it could have been early Neanderthals making those wooden tools, but they are a variety of tools made very skillfully by people who really knew the material they were working in, choosing specific trees, a specific species of tree, a specific kind of tree, and then spending a lot of time working on these to make spears, throwing sticks, digging sticks, and other kinds of artifacts out of wood. So most of that evidence has disappeared because wood doesn't survive well, but that shows us the complexity of Neanderthals and their predecessors. And things like marine exploitation. Again, 20 years ago, it seemed that Homo sapiens were the ones that were really exploiting the marine resources, and Neanderthals didn't. Well, we now know Neanderthals were exploiting marine resources at times. Neanderthals living on the coast were collecting shellfish, and they were eating even marine mammals at times. Remains of dolphin are found there, of seal. Now, because they may have scavenged some of these, maybe a dolphin washed up near the cave, but they ate it. But they certainly collected enough shellfish that they were purposely doing that. And they were in Gibraltar. We found evidence of Neanderthals taking limpets and then baking them as people do today. As your fire is dying down, you drop your limpet shells into the fire and they open up naturally from the fire. And that's what Neanderthals seem to have done in Vanguard Cave in Gibraltar.
Smart people.
So they were much more like us than we used to think. And that's why this old image of the brutal Neanderthal, the ape-like Neanderthal that used to be around, we have to throw that out, certainly.
What kind of clothes did they wear?
Well, unfortunately, the evidence of that has disappeared. I'm sure they must have had clothing. They were certainly, they had the technology to work animal skins. And they must have worn clothing at times when it was really cold. Maybe they didn't when it was warm. They didn't need to, but perhaps it's comfortable to cover bits of your body if you're going through, some coarse vegetation. You're going to, if you're wearing clothing, that will protect you a bit. Maybe they had shoes, but again, not direct evidence of that. But yes, I'm sure they had clothing when it was really cold. Of course, they must have had clothing. Maybe they didn't have sewing needles. Perhaps that's something that came with Homo sapiens. And if you've got sewing needles, you can produce better insulation for your clothing, for your tents, to cover your baby, to keep your baby warm, which is critical for survival. So maybe they didn't have that, but I'm sure they had clothing. I'm sure they were skilled at working animal skins. Yeah.
You mentioned the hashtag that was carved into a rock, I believe, by a Neanderthal.
Yes.
And since they were so similar to us, and you're saying that the difference that we thought was once there is getting narrower and narrower, is it reasonable to assume then that they had language similar to ours?
I'm sure they were talking to each other. I think the language, of course, again, there are experts in this that you could talk to. But for me, I think the complexity of Neanderthal life as we know it means they must have had language. I think if they're doing cooperative hunting, for example, then that suggests they've got language, complex communication. But of course, if they really separated from us more than 500,000 years ago, their language could have evolved in such a different way that it would be unlike any language we can imagine today from the diversity of languages around the world today. So what that language was like, we can't say. I think it was probably a practical language for what they, it was based on their everyday activities, what they were doing now, maybe what they were doing tomorrow. It probably wasn't a language that had, very complex terminology. It didn't maybe have a lot of abstractions. It didn't talk about the deep past or the distant future. It didn't probably talk much about imaginary worlds, but it was probably a practical language, and I'm sure they had that capability. And there's one side I haven't mentioned in terms of Neanderthal complexity. So there's a remarkable site deep in a cave, Bruniquel Cave in France. Deep in the cave, well beyond any daylight, explorers found 2 oval structures made out of stalagmites. So someone had systematically broken stalagmites and built dry stone walls in oval shapes. They'd had fires down there because it was completely black, so completely dark. So they must have had fires, and there's evidence of these fires, of them burning both charcoal and animal bones and animal fat for these fires. When these stalagmites were dated, these stalagmite rings, they were dated to 176,000 years ago. Deep in this cave. And at that time in southern France, we only think Neanderthals were around. So very likely this was made by Neanderthals. Why they did it deep in the cave? Some people think this is some, religious structure, some ritual structure. I think they could have actually been living down there at times, because 176,000 years ago was pretty cold. It might have actually been warmer in the cave, sheltered. Okay, they'd have needed fires to keep burning down there. But maybe actually these are hut structures. Now the floor has not been excavated yet. And so we don't know if there will be living debris down there where they're actually living, or were these some special ritual structures. So there's a lot to learn about that. But it shows the complexity and the fact that they've gone and systematically broken stalagmites to a given size to build these walls. Again, that's cooperative behaviour. That wasn't just 1 or 2 people doing that. It was groups. And again, that suggests language to communicate something as complex as that. And back to your question about music. I know I didn't answer that one. Whether they could have had music. There's a controversial flute made out of cave bear bone from a site called Juvbabe. And that is claimed to have been made by Neanderthal.
Is that the Slovenian
site? That's right. So there are holes.
Yeah, I'm from Slovenia.
Oh, right. Yeah, you know it. So there are holes in this bone, which seem to be spaced out as though it is a flute. And people have replicated it and played it as a flute. But other archaeologists have looked at these holes and think that they've been produced by animal teeth. So cave bear teeth and hyena and lion teeth, fit into those holes equally. So it could be an accidental product that we recognise as a musical instrument. So I'm cautious about that being a musical instrument. And the best ones who know about come from 40,000 years onwards. So when we come to Homo Sapiens in Germany, for example, there are flutes made out of vulture bones and even out of ivory, very difficult material. And those undoubtedly are musical instruments. For Neanderthals, yeah, I'm sure they had some kind of music. I mean, those people who are breaking off all these stalagmites deep in that cave, you can even play stalagmites like xylophones. So I don't see why the Neanderthals couldn't have been drumming in those caves with stalagmites. They'd make a nice ringing sound. Why not?
Okay, we talked a lot about how similar we are to Neanderthals as Homo sapiens, but yet we are not the same. What are some of the differences between us and them?
Well, obviously in the skeleton, we talked a bit about the body shape. So if we look at their skeletons,
like the barrel chest,
they're
the
overall,
bigger organs.
They're short and wide, very muscular, deep muscle insertions, very powerfully built, especially in the upper body. This, as you say, barrel-chested and much bigger lungs in there, wide shoulders. In the head, there are a number of differences, and my PhD was about looking at the skull of Neanderthals and Homo sapiens and comparing them, looking at the similarities and differences. So they've got a big brain as big as ours. It's a different shape, though. It's longer and lower, so the brain case is longer and lower. There's, of course, this characteristic big brow ridge at the front, which all of these earlier humans have got, so lower. And their face, of course, very distinctive. We talked about this before, I know. I think you mentioned it on your Twitter feed about the big Neanderthal nose. So
Yes.
the middle of the face.
I asked you if you can tell if I have more Neanderthal DNA
That's right.
because of my big nose.
A lot of us have got big noses, prominent noses, and wide noses. And the fact is, Neanderthals had really extraordinary noses. The nose was pulled forwards, it was very high, and it was very wide. And that's really unique to them as a group. And it was accentuated because the middle of the face is pulled forwards and the cheekbones sweep back. So I think if we could have seen a Neanderthal coming towards us, that nose would have been one of the most striking features that we would see first. So why it's there, some people think it could be respiration, that it helped them, breathing a lot of air in, maybe warming and humidifying the air, but it could also just be functional, that they require a lot of air to come in, and so that big nasal opening is letting them get air down to their lungs, so they're having to breathe in a lot of air, and that nose is part of that system. So this distinctive face with the middle pulled forwards, not much of a chin on the lower jaw, little distinctive muscle markings from one skull, from their skulls compared with ours, and the ear bones. So the middle ear and the inner ear, tiny little bones in there, which are concerned with our balance and with our hearing. The middle and inner ear bones of Neanderthals are a different shape to ours. And so from CT scanning, even though when we haven't seen the bones because they're buried inside the skull, we can tell that Neanderthals were different from us in their ear bone shapes. And these ear bone shapes are laid down before birth. So the fetus already has these ear bone shapes laid down, and it's different in Neanderthals. So Neanderthals and us are more different in ear bone shape than gorillas are compared with chimpanzees. So it's a very striking difference. What does it mean? Well, functionally, probably doesn't mean much. So the hearing range, we can estimate the hearing range, and it's been done for the people at Atapuerca in the Cima de los Huesos. So we have their ear bones from more than 400,000 years ago, and already at that time, their hearing range was very similar to ours. So there's no evidence these hearing bone differences are to do with inferior or superior hearing, but it may be that it's just the whole shape of the head is different in Neanderthals. They've got a longer and lower skull, which is almost spherical in shape. And so the ear bones, which sit down here, they've got to continue to function, even as the skull is a different shape. They've got to continue connecting to each other. So it may just be that that's the way they evolved over several 100,000 years as the skull shape evolved to be different from ours. So their ear bones had to keep up with that change, if you like, and had to change their shape as well. But it is a distinctive feature. So that's in their skeletons. Obviously, we've talked a bit about their culture and how it may have been similar to ours in many ways, but with some differences. Their genetics, of course, their DNA is different in some ways from ours. There are bits of DNA they have and we don't have, and we have and they don't have. So when we look at the interbreeding, and I don't know how much we're going to be able to talk about the interbreeding between us and Neanderthals, but what's interesting is when you look at the DNA today of humans today and look where the Neanderthal DNA is in our modern genomes, much of it is just scattered right through our genomes, and different people have different bits of Neanderthal DNA in them. And equally, the Denisovans in the Far East, they've interbred with Homo sapiens, and people in the Far East and Southeast Asia and Australia and so on, they've got Denisovan DNA in them. So when you look at the Denisovan DNA, equally it's scattered right through genomes of people today. But there are areas of the genome where you never find Neanderthal or Denisovan DNA, so-called deserts of introgression, deserts where there's no sign of Neanderthal or Denisovan DNA. And we know functionally that those areas of the genome contain coding for the brain and for the vocal tract. So that does suggest there was something that couldn't be tolerated in the hybrids in those areas. So hybrid DNA could not be tolerated in those bits of the genome. So they give us a clue that there were some functional differences in the genomes between us and Neanderthals and Denisovans. What they are exactly, we don't know. But in many ways, obviously, the interbreeding was compatible. Otherwise, there wouldn't be Neanderthal DNA today. You and I probably have around 2% Neanderthal DNA in our genomes from interbreeding maybe 50,000 years ago.
I just wanted to ask you this about the differences, maybe connecting those with culture. Is it true that throughout the, 300,000 year history they existed, maybe it was even more, they managed to survive different climates, but their culture and their tools didn't really change? So unlike us, they didn't invent new stuff regularly.
Well, I think it's difficult to say. In terms of stone tools, yes, the stone tools don't change dramatically. When we get to Homo sapiens from 45,000 years ago, we see much greater complexity. Many new tools, many new cultures and differences grow up quite rapidly. It looks like change is accelerating and building on change. So it kind of really takes off. And much greater use of bone and antler and ivory, which are difficult to work materials. But the Neanderthals did change through time, and there are different Neanderthal technologies. So there are so-called, we see Neanderthal tools described as Mikokian or Ziletian, Chateaubriandian, and so on. So there are these subgroups of Neanderthal tool types, which are recognized by archaeologists. So these may represent distinct Neanderthal populations that carried on through time with their own distinctive traditions. But yes, innovation was slower. You could say the same thing for Homo sapiens, though. If we look at change in Africa of stone tools between, let's say, 300,000 and 100,000, there is not much change even in Africa in the stone tools. There may be a lot going on under the surface that we can't see in the stone tools, but the stone tools themselves do not show remarkable diversity until later on, when we are, from about 45,000, we suddenly see a proliferation of new tool types in Homo sapiens. But earlier on for us and the Neanderthals, the pace of change was, in stone tools at least, was much slower.
You mentioned that you and I probably have about 2% of Neanderthal DNA, so implying that different populations today have different percentages of Neanderthal DNA in them. I remember when I was going to university, one of our cultural anthropology professors told us of a 19th century theory of some French anthropologist, his name totally escapes me now, who was convinced that us Balkan people have much more Neanderthal blood. Today we would say DNA probably,
Yes.
than anybody else. I think it was because they thought there was a group of Neanderthals that managed to survive in the Balkan mountains until very late or something. But which populations actually do have more Neanderthal DNA? And I'm totally going to rock my new Neanderthal identity if you say it was the Balkans.
Yes, it wasn't the Balkans, I'm sorry to say. It wasn't anywhere in Europe, in fact, as far as we know. So again, you need to talk to a geneticist to get the precise figures. But first of all, the lowest levels of Neanderthal DNA are found in sub-Saharan Africa. So Neanderthals never penetrated, even if we mentioned they might have got into North Africa, perhaps, but they never penetrated far south. So modern sub-Saharan African populations have very low levels of Neanderthal DNA, unless it's been introduced more recently by more recent interbreeding. So the highest levels actually are found surprisingly in places like China. So that's kind of surprising when you think where Neanderthals were mainly living. And there were views that perhaps there were Neanderthals living in Eastern Asia, and as Homo sapiens spread eastwards, they actually interbred with Neanderthals and added on a bit more Neanderthal DNA. That now seems to be much less likely an explanation. The explanation seems to be that the percentage in Europeans has been diluted. So we've had gene pool around the Mediterranean, which has brought in sub-Saharan African populations that had less Neanderthal DNA. Populations in Arabia and places like that may have had less Neanderthal DNA. And so actually there's been gene flow that's diluted the formerly higher levels. So it's only a small amount. The Chinese, maybe about 0.2 or 0.3% on average higher than Europeans. But it could be that the European level has actually been reduced slightly by later interbreeding with the Roman Empire, but the spread of Islam, but all of these changes of farmers coming from the Levant into Europe, bringing new behaviours and bringing their DNA. So it's diluted the European figures. So the figures probably were all higher 45,000 years ago. Soon after the interbreeding, there was probably a level amount of Neanderthal DNA, and maybe 5% across the area. And then it's been selected away, and in Europe it's been diluted down even further to around that 2% level, slightly higher in China.
Let's talk about that interbreeding event that happened. When did you say it was? Because there was several.
Yeah, so we think
one was 300,000.
Yeah, we think there was one, maybe 300,000 or more years ago, still poorly known, which took some Sapiens DNA into Neanderthals and maybe a bit of Neanderthal DNA into Sapiens around the Mediterranean and North Africa. And then there was the main event. So Homo sapiens, having made a few excursions out of Africa and spreading out of Africa now and again, around 60,000 years ago on genetic estimates, a population came out of Northeast Africa, and that was the population that interbred and had the main interbreeding event with Neanderthals, which is what's in our DNA today outside of Africa. So it could have happened maybe 50,000 years ago, probably somewhere in Western Asia. And then as the Homo sapiens population spread out from there, they took that bit of Neanderthal DNA with them into Europe, towards China, down into Australia, over into the Americas eventually. And so that level was, obviously I've mentioned it could have been 5 or 10% to begin with, but it very rapidly was selected down to the levels we find it today, closer to 2%. But that 2% remains. Much of it is not doing anything. It's just sitting there in our DNA, but some bits are functionally active. And so we now know that our immune systems outside of Africa owe something to Neanderthal DNA. It actually, helped our immune systems. So when you think about it, obviously coming out of Africa, we had no natural immunities to the diseases that were local to Europe and Asia. The Neanderthals have been evolving there for hundreds of thousands of years and had developed natural immunities to the local diseases, to the parasites and so on. By interbreeding with the Neanderthals, we got a quick fix to our immune system, and that helped us 50,000 years ago. Nowadays, it's not quite so useful because it seems that some of those Neanderthal immune systems are behind some autoimmune diseases that we have today. So Crohn's disease, so things like Crohn's disease, biliary cirrhosis, some of these may be due to the presence of Neanderthal DNA. There's even a peculiar correlation at a small level with addictive behavior in having Neanderthal DNA. The inability to give up smoking, there seems to be some connection with Neanderthal DNA, which seems odd because there was no tobacco around when we met Neanderthals 50,000 years ago. It came from the New World. But it could be something about repetitive behavior. So maybe Neanderthals, maybe it was, if you're going to make a fire, you really have to persist at it to do it. And maybe that was something that was useful, that kind of persistent behavior. Nowadays, of course, bad news for us with betting shops and online betting around the corner, and alcohol and tobacco and all those things. So it could be that, that's what, and of course, people start listing all the things that may be due to having Neanderthal genes, that, being
all the bad
being
stuff.
A morning person, being bipolar, being depressed, whatever. These could all be due to Neanderthal DNA, people say. And you might think, well, no wonder the Neanderthals died out. They had all these things wrong with them. But of course, that's what the DNA is doing in our genomes today. We want to know what it was doing. What were those genes doing in Neanderthal genomes? And we don't know, of course. And genes don't work in isolation. They work together. So, of course, in our genome, some of these bits of DNA may not be working the way they should have been working in Neanderthal genomes because they've been transferred, if you like, to a foreign genome. So we'd like to know what those bits of DNA were doing for Neanderthals, and we don't know the answer to that.
So when you send your DNA to one of these testing companies and it comes back, 3% Neanderthal, does that actually tell you something, or is that more of a commercial
they don't,
product?
Doing whole genomes now is much cheaper. So if you can get your whole genome done, then you'll get a pretty accurate count of your Neanderthal levels. But of course, the commercial ones tend to select bits of the genome. So you get a figure that's approximate. So I've had it done twice, and I think one of mine was about 2.5% and one of them was 1.7%. If I average those, it's about the right level. So, you get a rough guide, but it may not be perfect. You need your whole genome done to get the most
But
accurate
would
figure.
that right?
But it doesn't tell
But
you.
would that tell you anything about your behavior or anything?
Well, some of these will give you extra information about your health. What are your risk factors to develop some of these diseases? And that is where there can be links with Neanderthal DNA. They don't necessarily spell that out, but it may be that if you have a higher risk, of developing, a particular cancer, that could be due to bits of Neanderthal DNA. We know that COVID susceptibility, there are some bits of Neanderthal DNA which gave people protection against COVID and other bits that made them more susceptible. And this may be due to previous selection. So, for example, we've had these plagues which have swept through, of course, Europe many times. There might have been bits of Neanderthal DNA which gave resistance to those particular diseases, 500 or 1,000 years ago. And now, of course, they may be doing the same thing for better or worse with a disease like COVID.
Professor, we once thought, at least I was taught that in school, that once Homo sapiens turns up, we kind of supplant, if not exterminate, Neanderthals. But you told me that they were already on a downhill slope, that they already had like weaker numbers, weaker DNA pool. So is it the other way around now? We had nothing to do with their demise?
I mean, again, it depends who you ask. So I think that it's a combination of features that the Neanderthals disappeared physically, because they didn't disappear completely, because their DNA, as we've said, lives on in us today. But I think it was a combination of features. We've mentioned, yes, their low diversity, but near the end of their time, they perhaps were a threatened species, and it wouldn't have needed much to tip them over the edge. The climate was very unstable. That certainly didn't help them. To have a competing species that turns up that's going to want to, it's going to be hunting. They're going to be hunting the same foods, collecting the same plant resources, wanting to live in the best territories for hunting and gathering, wanting to live in the best cave sites, and so on. So I think there was an economic competition between these two groups. And depending on the local circumstances, at times maybe it favoured the Neanderthals, and at other times it favoured Homo sapiens. But overall, Homo sapiens grew their numbers at the expense of the Neanderthals. And I think there's a clue also even in the interbreeding. So I wrote a paper a couple of years ago with my colleague Lucille Crett, and we argued there that even the interbreeding could have been part of Neanderthal extinction, because there's a strange pattern at the moment in the interbreeding that happened after 50,000 years ago. So we have early Homo sapiens genomes from after 50,000 years ago, and all of them show evidence of recent Neanderthal interbreeding, at least within the previous 5 or 10,000 years, sometimes even within a few generations. We have maybe a dozen Neanderthal genomes from the same time period. None of them show Homo sapiens DNA coming in recently. So that's a strange pattern. It may just be due to low samples of we don't have many Neanderthal genomes, but at the moment, it seems to be a one-way pattern of Neanderthal DNA going into Homo sapiens and not in the other direction. It may be that there simply wasn't interbreeding in both directions, that whatever mating patterns were going on, Homo sapiens, Neanderthal people were joining. They're choosing to join the Homo sapiens groups to interbreed. It may have been even capturing individuals. So some modern primate groups, some modern hunter-gatherer groups, if they run out of females, they will go and steal some from a neighbouring group. So maybe Homo sapiens actually stole Neanderthal females into their group to breed with them.
Wow, fascinating.
But whether it was voluntary or not, this movement of Neanderthal breeding individuals into Homo sapiens means that they're being lost from the Neanderthal breeding pool. And if you haven't got many people, that's very bad news. If you're losing your prime age breeding individuals to this other population, that is going to add to the extinction problem. The numbers are going to shrink, the diversity is going to shrink, because your prime age individuals are going voluntarily or involuntarily to join the breeding pool of another species.
So if I understand you correctly, their demise is due to many complicated factors.
Yes, it is.
Climate change.
Environment, climate change could be certainly part of it. diseases, of course, brought by Homo sapiens, equally diseases, from Neanderthals and Denisovans. It could go both ways. Some people suggested epidemics, but I don't think that's going to be the explanation because, and what we've got to do, of course, is account for not only the disappearance of Neanderthals, but of course we mentioned these other humans, the Denisovans, they disappeared too. And there were other human species around in Southeast Asia. They disappeared too. So the common factor, of course, seems to be the spread of Homo sapiens. So that's why I think we're implicated, but it doesn't mean we were hunting these groups to extinction, fighting them and killing them, maybe eating them, make it even worse. I think that it's indirect, it's economic competition. And at times these groups coexisted probably peacefully. Maybe they exchanged partners peacefully. But the long-term pattern was Neanderthal decline and physical extinction.
Okay. Yeah, I mean, that image of like all Homo sapiens banding together with a plan to exterminate all Neanderthals was a bit silly to begin with, to be honest.
Yes, I certainly think so. And equally, Homo sapiens are pretty good at doing each other in. We know that. It's not just, killing Neanderthals. Yeah.
Word.
Yeah.
Okay, we're approaching the end, Professor. So I hope you allow me to steer the conversation in a different direction for a couple of minutes that we have left. You're probably too busy with actual work to listen to podcasts and watch Netflix. But there's been a big surge of these kind of pseudoscientific crackpot human origin theories in the mainstream lately. Stuff like ancient aliens and that annoying guy, Graham Hancock, who's regularly appearing on Joe Rogan's podcast and even has a shockingly bad Netflix show about some lost advanced ice age civilizations or something. To what do you attribute this proliferation of this type of junk?
Well, I think they tell very simple stories sometimes when the reality is much more complicated. They appeal to the unknown, the fact that there are gaps in our evidence. And so, these people fill in those gaps with their own crazy theories. And there's also a kind of, there's maybe an anti-science agenda, an anti-expert agenda. Here's kind of someone who's self-taught. They've learnt this themselves. The knowledge has not been handed down to them. They've learnt it themselves, and they're up against these experts. They're pioneering a different way of thinking, and these experts are kind of the conservative reactionary forces shutting down these alternative views. So maybe there's an anti-science agenda in there even. But it was good that, if people listening to this get a chance to view the Joe Rogan debate between Flint Dibble and Graham Hancock.
I've just seen that.
I mean, there's hours of it, but it really is. If you got the stamina, these are great to watch because in the end, Graham Hancock admits that he doesn't have any direct evidence for the existence of his ancient civilization that he claims was behind all this spread of knowledge 10,000 years ago.
But the comments are still kind of dispiriting and depressing under the video. They're like, people are still accusing the archaeologist Flint Dibble that he's being arrogant and that he's laughing when Graham Hancock
I mean, we get
speaks.
the same thing from creationists. I got involved with public debates with a creationist, a top creationist 30 years ago in London. It's the same sort of attack on knowledge. People claim that, debate is being shut down. And it's like climate change debate. 99.99% of the evidence shows that the Earth's climate is changing in the direction predicted by climate change experts. And yet there's still people who will say it's a conspiracy. They're making it up. They're twisting the evidence. The Earth is not getting warmer. Or if it is, it's just natural processes, which is, it's true. Climate change is happening all the time. In the Earth's past, it's happened all the time. But what's happening now is exceptional. And it seems to be linked with our behavior.
Why do you think so many people are more convinced we are a product of breeding with aliens with like zero evidence than in evolution with plenty of evidence? Are we just like ashamed of our lowly origins, as people used to say?
Yeah, it's difficult to understand. It's also difficult to understand creationists. You're dealing with a completely different mindset. And it's difficult to get inside the heads of these people and how they think. I think if we go into it with an open mind, and I've had to change my mind about a lot of things along the way, and it's been better for me to do that. And the good thing is, I've changed my mind about Homo heidelbergensis being our ancestor. 20 years ago, if you'd asked me about Neanderthal interbreeding, I'd have said, well, if it happened, it was trivial and we'd not find any evidence of it today. And I was wrong. And I've had to admit I was wrong about that. And once you've admitted you're wrong about something, it's actually easier to admit the next time that you've been wrong about something. And I think everyone should be able to question their own beliefs as well as other people's beliefs. And I think that's what these people lack. They lack a self-critical judgment to actually criticize, look critically at their own beliefs as well as that of the other people they don't agree with.
What's the quickest way to disarm people who don't believe in evolution in 2024?
Well, it depends how much time you've got, but I think if you show them the skeleton of a chimpanzee stripped bare and the skeleton of a human, and we've got an example in our human evolution exhibit in London, we've got a chimpanzee skeleton there in the same display case as a Homo Sapiens skeleton, and every element of the skeleton is the same. They're differently shaped and proportioned because of the different ways of life and adaptations and evolution. These have been separated by maybe 7 million years, but the similarities are striking. And even the people who didn't believe in evolution 150 years ago, people like Owen, who founded the Natural History Museum, he couldn't deny the major structural similarities that were there. Okay, he thought God was behind this design, but, those structural similarities are there regardless. And there's all the genetic data too, of course. So it depends how much time you've got. But I would say, just as a striking thing, just look at a chimpanzee skeleton and compare it with a human skeleton and say, are these similar or not? And maybe for comparison, have a dog skeleton or a horse skeleton next to it and say, how similar are these compared with that?
What do you think is behind this last question, this anti-science agenda lately? Because when I was growing up, people wouldn't say this stuff out loud. Maybe they were thinking it, but kind of people would be a little bit embarrassed or ashamed to make these sort of crazy sweeping claims.
Well,
without any.
I don't want to implicate you in this, but podcasts, the fact that social media is now so much part of it. I mean, there weren't all these different ways of transmitting all these crazy theories now, but anyone now can set up their own account, website, podcast, whatever, to proliferate these crazy ideas. And they have a life of their own. We see the way that, as you've said, you've looked at the commentaries on the Graham Hancock debate. These things can just take off. And, I suffer it too. I get plenty of abuse on social media too. It comes with it, and you have to just develop a thick skin, unfortunately, as a scientist. You're accused of all kinds of conspiracies. And it's sad.
Such as?
Well, I'm hiding evidence. The museum is hiding evidence. The creationists accuse us of that. We're hiding evidence that disproves evolution. We only put out the evidence that suits us. There's a famous example with the creationists. I don't know how much time we've got now, but there's Guadeloupe in the West Indies, the island of Guadeloupe. A skeleton was found there in the early 1800s by the French, and it was completely encased in a rocky sand. So beach rock, we can call it. And, but it was obviously a Homo sapiens skeleton encased in beach rock. And it was taken as a curiosity because it seemed to be like a fossilized human skeleton in rock. So the French took it, and this was the Napoleonic Wars. And so then the ship that was carrying it got captured by a British ship. And so they found this giant, this skeleton in beach rock from Guadeloupe, and it ended up in the British Museum. And now it's ended up in our museum. And it was on display for many years as an example of rapid fossilization of a human skeleton. But no one thought it was very old because that beach rock contains charcoal and pottery and things like that. So it was known to be recent, but a creationist got hold of this story and said the museum had this example actually of a victim of Noah's flood. So this skeleton was actually buried during the time of the flood. It was fossilized by the weight of the thick floodwaters. And these rocks are Miocene in age. So this, in geological terms, this is a very ancient body, and the museum has taken it off display and is hiding it as an example because it's proof of Noah's flood. I mean, it seems crazy to us, but that's what they published. And I had to deal with this for years afterwards. I still do have to deal with it now and again, of people claiming we've hidden a skeleton that proves Noah's flood. This was a victim of Noah's flood. I mean, it's laughable, but, I have a thick stack of correspondence. I had to write papers refuting this story, believe it or not. There we are. Yep.
Well, I'm not sure if I should laugh or cry about this.
Yeah.
It's certainly amusing, but I know that if you're spending decades on actual research into human origins, it stops being amusing at a certain point.
I have to laugh at it now, but it wasn't funny at the time when it started.
Right. Professor, thank you so much for taking the time yet again. Really appreciate it. Are you still active on Twitter? Where can people find you and your work?
Yes, I'm active on Twitter, and I'll be. There's this Neanderthal documentary on Netflix today, so I may be, commenting on that later on too about Shanidar.
Oh, perfect.
Yeah, so this.
What's it called? The show?
I can't even remember the title. That's a shame. Secrets of the Neanderthals. Yes, but it focuses
Secrets of the Neanderthals.
on new discoveries from Shanidar Cave of a new Neanderthal partial skeleton with a face, and they've got a fantastic reconstruction of this Neanderthal woman that lived maybe 75,000 years ago. So that's on Netflix today.
Fantastic.
And I'll no doubt be commenting on that. It's shown later on today.
All right, perfect. So Netflix has done something to kind of recalibrate after that Graham Hancock.
Yes, and even the
thing.
Cave of Bones, the Homo naledi story, which we haven't got time to talk about again now, but, the claims by Lee Berger that Homo naledi was making art and burying its dead and making fires in the cave. That was another Netflix documentary that wasn't Netflix's finest hour.
Okay. Thanks again, Professor. Always a pleasure.
That's all right. Thank you. Good to speak to you.
Thank you so much for listening. If you liked what you heard, please consider subscribing to Smart Cookies on YouTube. What else is there? Apple Podcasts and Spotify. And if you really liked what you heard, feel free to become my patron on Patreon by going to Patreon and becoming my patron. It's really easy. Just type Smart Cookies Podcast in there. You should be able to find me. Last but not least, I have to thank the absolute legends that are my producers on this show, my existing patrons on Patreon: Aida, Mancian, Miha Medved, Medinho, Gordon, Jurechuk, Lorenzo, Mila, Carmen, Taichi, Goran, and Veronica. Without you guys, this show wouldn't exist. So massive thanks. And see you in the next episode. Bye.